For lesson 1.5, we're talking about functions and being able to analyze different situations. But for number 1, we need to realize that if something is a function, there is a unique output for an input. So which means that 4 can go to a -1, that's fine, but 4 cannot go to -9 or 15. So that's good. 3 goes to -6 and 3 doesn't go to anything else. 2 goes to -1, but 2 also goes to 5, which tells me that this is not a function. And in order to fix this, what you would do is you would either change the 2, -1 or the 2, 5, and maybe we just say that this is, instead of a 2, 5, it's a 12, 5. This is now a function. For number 2, the number of calories you have burned since midnight at any time during the day would end up being a function because every time of day has a unique number of calories burned. I can't at 1:30 in the afternoon say that I burned 55 calories this hour and 75 calories this hour. That just wouldn't make any sense. So yes, number 2 is a function. Number 4, the -12 goes to 25 and it doesn't go to anything else. The -8 goes to 25, doesn't go to anything else. The same with the -6 and the -4, which means yes, this is a function. And this is rather confusing because, like, well, that means that each input has to go to its own output. It just has to have a unique output for every input, which means that I can't have the -25 go to 12, or sorry, the -12 go to 25, and what if it was -12 and 61? Okay, then it would not be a function. So in this case, number 4 is a function. Number 4. Number 6, we can talk about something called the vertical line test as one measure when we have a graph. If I draw a vertical line, infinite number of vertical lines across the graph, and any one of those lines crosses the function or crosses the relation any more than one time, it is not a function. But in this case, any time I go across this graph, I'm only going across once. So yes, this is a function. To contrast that, I can do the same thing for number 5. It's good, it's good, it's good. Boom, look at that. It crosses once, it crosses twice. This is not a function. To create a function, to make this a function instead of what we have here, we could erase that last part, and now it's a function. We could also shift it over, and I can't do that here with my device, but I could shift it over, and it would also be a function then. For numbers 7 through 12, we're trying to analyze a situation about 2 or 3 different cars. For number 7, which car has its cruise control on and how do you know? Well, if it's on cruise control, that means that it's going at a constant rate of speed. If you look at A, it's going nice and straight, which means that the speed is remaining constant. B starts off the acceleration slower and then gets faster as we get up towards the second part of the visible portion of the graph. Therefore, we can say that car A has its cruise control on because it has a constant rate of speed. For number 8, which car is accelerating? How do you know? Well, that would be car B. And I would just need for you to make sure that you can explain how you know that the car B is accelerating, and it has a whole lot to do with the second half of the visible portion of the graph. The interval in figure 1 where car A seems to be going faster than car B. Okay. Car A, so if we look at an interval, car A is going faster from this point in time to this point in time. So what we can do is we can say that it is going faster, and if we use that interval notation, between 0 seconds or minutes, or it doesn't say the units that we're using, but between 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 12. So I'm going to call it 12.8. Okay. Then the interval, actually let's go right here. And so I'm not going to have this be a closed, I'm going to have this be open. So I know for sure that we've got some stuff going on here, or I think stuff's going on here where car A is a little bit ahead at 0 seconds, and then 12.8 seconds they are then tied. So car B is not ahead at 12.8 seconds, but from that point on it is. For number 11, what in the graph indicates the speed of the cars? The speed of the cars is indicated by the rate of change. And you've probably heard this referred to as slope. Now that third car gets thrown into the mix. They're all going to the same destination. If the distance is 12 units from the origin, which car do you predict will arrive first? Well, I know that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do you think is happening here? I'm going to erase a little bit, and I will tell you that it's not car C, because car C is still back at just 4 units. 1, 2, 3, 4 units. He's only moved 4 miles or 4 meters or 4 something, whereas car A and B have a little bit of a race going on. For numbers 13 through 21, we haven't spent a lot of time talking about it this year, but as hopefully you have begun to learn, these things are spiraling back. You've talked about domain and range in the past, and we're going to continue working on it throughout the course of the school year. So for number 14, A, we're talking about the domain. These arrows tell me that they go on forever. So the domain for number 14 can go on, the x value is the domain. Okay? What we're trying to do is we're trying to figure out what x values I can use for this function or relation. So in this case, it's a function, and it's going off into negative infinity. And then on this side, it's going up to positive, or over to the right, positive infinity. So our domain would be open negative infinity to positive infinity. For the range, we know that it actually starts explicitly with that dot at -1. So if you notice here, down at -1, the ranges are y values. But it goes up to positive infinity. Number 16. The domain, again, is our x values. So if you're looking at this oval or this ellipse, it's going to go from here to here. And it's a matter of knowing what those numbers look like. Well, it's kind of blocked, it's not written very well. But the domain for this is -4 to +2. The range is taking our y values. Okay, we're trying to build a box around this ellipse. The height of it would start at -2 and end at +2. So it's going from -2 here to +2 here. For number 18, 18 is a little bit tricky because it's just a vertical line. Well, how far left or how far right can we go? It's just 2. So sometimes it's written with curly braces around it. But the range is a little bit more interesting. So the range starts down here and ends up here, but it has an open circle. So because it starts down here, we need to figure out, well, this is 1, 2, 3, 4, 5 blocks up to get to 2, which means that it will be 0.4. So if we take 2 and divide it by 5 different blocks, you would get 0.4, and it would go up to 6. But again, that open circle. So we can't include the 6. It goes all the way up, reaching infinitely close to 6, but not actually getting to it. For number 20, the domain is no longer a line or a segment, it's just a series of points. So when we're looking at the domain for number 20, we have a curly brace, and we know that it is -1, 0, 1, 2, and 3. Close the curly brace. And the reason for that is our x values, -1, 0, 1, 2, 3. Okay, looking at the x-axis. For the y values, the range, we're looking at where they fall on the y-axis. So similarly, we'll have curly brace, and we start down at -5, -2, 1, 4, and 7. So a little bit different way of writing it because it's not a line or a line segment or array, it's just a series of points. And if you notice, the -1 matches up with the -5, the 0 matches up with the -2, the 1 matches up with a 1, and so on. So each input has its own unique output. Hopefully this helps. Reach out if you have any questions.